Okay, so they tell us that we're going to do a race. And the first part of the race is going to be on a bicycle. Let's pretend it's a bicycle. And after that, we are going to run. All right. Now, this first part here on the bicycle, they say is 22.5 miles. Then we jump off the bicycle and we're going to run for 3.5 miles. So the whole trip, right? What is that? This plus this, 26. That's like a marathon, right? 26 miles. Why don't we give each component its own dirt? DRT, dirt. D equals RT. Distance equals rate times time. Distance equals rate times time. Let's focus on just the bicycle. In the math problem, so they said that the bicycle, they tell us that R is 20.6 miles per hour, and the distance is 22.5. Look, focus just on the bicycle. Distance equals rate times time. We know the distance. They told us how much in the bicycle, and they told us how fast. If you divide this into that, you're going to get the time. So let's take 22.5 and let's divide it by 20.6. So I'm typing that in for us now. And so this time is about 1.0922, and it keeps going. Now, that's just the bicycle. We know everything about the bike. We know the distance, we know the rate, and we just found the time that it takes for the bicycle. Now, over here for the person, we know that 3.5 goes in for the distance. Do we know how fast they're running? That's the goal. Do we know the time? We don't know that either. So forget about the running part. Go to the end, go to the finish line. In the finish line, we know the distance is 26 miles. And in the math problem, it says that the average speed for the whole race, so that goes in for R. At the end of the day, when you go home, you tell them that your average speed was 10.1 miles per hour. That's a combination. That's a combination of the bicycle and you running. So look, pause. If the bicycle was 20.6 miles per hour, but at the end of the day, it was 10.1 miles per hour, you know that you ran slow because it has to weigh you down. We got to take the 20.6 and bring it down to 10.1. So you know we can expect that our rate when we ran is going to be kind of slow. We'll get there. Forget about that. Go back over here. Go to the finish line. 26 miles in total, and the total rate was 10.1. Divide that into 26. Let's go 26 divided by 10.1, and that tells us that this time is about 2.5742. So your whole marathon took about 2.5 hours. The whole thing. That's your whole exercise, 2.5742 hours. But you know, boom, over here, that the bicycle took up this much time. So why don't we take the bicycle and subtract it from the whole trip? And that'll tell us the time that was spent running on our own 2 feet. So let's go 2.5742 minus 1.0922. And that tells us that the time spent running was about 1.4825 7426 hours. So you ran for about 1.5 hours. That's a long time. When I go run outside, I'm tired after 10 minutes. This tells you to run for 1.48 hours. You know, have fun with all that. So let's finish this. Let's take 3.5 and let's divide it by 1.48-ish. And that'll tell you your final answer here in red, 2.36 miles per hour. So you have to run about 2 miles per hour, 2.36 miles per hour, which is like a light jog. So that's manageable, you know? And that makes sense because if the bicycle was 20.6 miles per hour, which is fast, and you combine it with 2.36 miles per hour, which is slow, it averages down to this much here. You see that? If you average this rate with this distance, this rate with this distance, it weighs it down to about 10.1 miles per hour. So final answer, 2.36 miles per hour.